Hi, this is Kevin Trainer, and welcome to part one of my tutorial for chapter three of the third edition of the Zelle Python book. And we're going to be working on arithmetic with numeric data types in this series of tutorials. And the first one that we're going to do, again, it's sort of a companion to what your assignment is going to be, is this. So let me create a new Python file. I'm having a hard time here. Oh, that's because I'm not on the project. So new Python file. And I'm going to call this integer division 1. So one of the things that's not completely intuitive to the new programmer is the fact that these integer data types have a special behavior in division. And one of the nice things about Python is that it has a special operator for integer division to remind us that it's going to behave a different way from the kind of division that goes on with floats. Okay, so let's see, getting the type a little bit bigger, get ourselves a little bit more room. Okay, that's good. So the file is integer division1.py. I'm going to use the formal names for the terms that we use in division. These are things that we learn in pretty early math. These are arithmetic terms. But it's pretty easy to forget them. So what I did is I've given you a link here to a page, and if we fire up the browser and we bring up that page, let's see if I can do that. What I'm going to have here, let's see if I can do this. Didn't completely work. Okay, so let's try again. There's my browser. And I bring up that resource page, and it's from mathonlymath.com, terms used in division. And so these are the terms, okay? So the number which is divided is called the dividend. I guess I remembered that, but it's not on the top of my head. The number which divides is called the divisor. The number which is the result of the division is called the quotient. And if there's any number left over, it's called the remainder. So we get the dividend, we get the divisor, we divide the dividend by the divisor. The answer is the quotient, and there may be a remainder. So these are the terms that we're going to use. And I promise not a whole lot of math, but this was pretty early arithmetic. It's just been a long time for some of us. Okay? All right. So what am I going to try to do? Well, I'm going to try to calculate the quotient for two integers provided by the users. Okay, so I'm just going to do a plain old integer division, and I'm going to show you the quotient. Am I going to show you the remainder? No, I'm not going to show you the remainder because that's what I'm going to have you do in your assignment. Okay? All right. Now let's start out with pseudocode. Okay? And I'm going to remind you that pseudocode is it's kind of a beginner step, But I think to completely think of pseudocode as only for beginners is unfair. Okay, I think you want to use pseudocode whenever you're not really absolutely sure how the code's going to go together. So when you're a beginner, that's pretty much all of your code. Okay, what'll happen over time is that certain simple parts of code will just be real clear to you from the beginning, and you'll be able to go right to the code and not have to do the pseudocode step. You might do pseudocode for one part of the problem. Okay, so it's really up to you how much of the pseudocode you're going to do. I was sort of a late bloomer. I was inclined to do a lot of pseudocode for a long time in my career. So I'm certainly not going to coach anybody away from the pseudocode because I've found it very valuable. Okay, so here's the pseudocode. Okay, and remember we had this a pattern that we were following back in the previous chapter called input process output, and so when I can, I want to make sure that I put our solution in those terms. So I've got three main parts of the solution. Get user input, that's the input. Do processing, that's our processing. And create output. Okay? So what would be the subparts of this get user input? Well, we would get the dividend. That's what we're going to, that's the number that's going to be divided from the user. And we want to make sure that we only get integers, okay? Because what we're doing is we're demonstrating that we understand integer division. So then we want to get the divisor. That's the number that we're dividing by from the user. Again, integer only. And then we want to do the processing. So that's where we're going to calculate that the quotient, that's the main answer, is equal to the dividend. And then we're going to use the integer division operator. So the dividend, integer divided by the divisor. And then we're going to create the output. We're going to print the quotient. Okay, so let's get going on this. Let's create a main, okay, which doesn't take any arguments. And what I'm going to do is I'm going to keep some of the pseudocode, and it's going to be comments in my main. Okay, so let's think about that. So the first one is going to be get user input, and going to want that to be indented because it's a code block under main. And then the second one is going to be do processing. So let's copy that. And I'm copying them out of my already baked version. Okay, and then the last one is going to be create output. And I've got this. So the question comes up from time to time. How much if pseudocode can you leave in a program? And I would say this kind of pseudocode. The reason why is that these are appropriate comments. Good comments to leave in a program are comments that reflect the intention of the code that they introduce. Okay, so get user input. It talks about the intention of what we're going to do, but it doesn't really explain how we're going to do it. The same for do processing, the same for create output. These lower level pieces of a code are too kind of operational, okay? And one of the reasons that we don't leave behind operational comments is people, as they change the code, they never maintain them. Okay? So these three comments that I've left in, they're probably going to be there for the life of the program, and nobody's really going to need to change them. But if I included all of the pseudocode in the program, it wouldn't be too long before the requirements kind of changed and we changed the code, and we never went back and changed the pseudocode. So comments that are very operational instead of intentional, they have a short life in terms of being accurate. And that's why we say that comments should be primarily intentional. Okay, so let's start to add some code. So when we're going to get the first of these inputs, right? Well, what's it going to look like? Well, we're going to store it in a variable called dividend. We're going to say input, please enter an integer for the dividend. Okay, now here's the change. We're not using eval anymore. Okay, we are specifically saying that we want only integers here. So this is going to do two things. One is it's going to turn the character string that the user types into an integer value to store that in under dividend. But the other thing is if the user types in something that's not an integer, if they type in 3.0, well, then the program's going to blow up. Now, in the long run, we're going to learn how to capture that and come back and politely ask the user to do what we asked them to do the first time. But for now, we're just going to take the blow up. Okay? All right. And then the second one's going to be pretty similar. Right? So we're just going to get the divisor. And I'll take that out of my already baked version as well. So we say divisor equals, we do int again because we want these to be integers. Please enter an integer for the divisor. Okay? All right, great. So what's the processing? Well, we pretty much had the processing code in our pseudocode. Our pseudocode was pretty much all the way down to Python, and that's okay. The fact is that some of our pseudocode is going to be pretty summarized and not Python-like, and some of it is just going to be Python code. That's okay. The pseudocode's there to help us along. It's kind of like the outline for a term paper that we're writing. And quite often the outline for a term paper that we're writing, some parts of the outline are really summarized because they're clear about what we're going to write. And other parts are more detailed because maybe we're less comfortable. Less comfortable in that part of our term paper. Okay, and then create the output. Now we want a print, and that's pretty clear what we're going to do. We're just going to do this. All right. We're going to print the quotient is quotient. All right. So, do we have enough code? No, we don't have enough code yet because we never called the code in the main. So we're going to invoke or call the method in the main. And I just want to point out what the right way to end a program is. Okay? If you look at this, there's a complaint that from the PEP 8 style guide. It says no new line at the end of the file. Okay, so let's put a return. It likes that, but what if we put spaces on that last line? It's going to give us a gray squiggly line that might be hard for you to see. And what's the complaint? blank line at end of file. So what does it want at the end of our program? It wants one new line, but no spaces on that line. It wants one empty line at the end. Now that's pretty particular, but that's the style guide for you. All right? Okay, so time to test. Okay, so now we're going to come over and we're going to run integer division 1. And I'll make this a little bigger so we can see the output. Please enter an integer for the dividend. Let's say 3. Please enter an integer for the divisor. Let's say 2. And it says the quotient is 1. Okay, does that divide evenly? No, there's a remainder, but that's not part of our current problem. So that's good. If we, we tested with some values that definitely make sense. Now let's do a little more testing. Let's kind of test the edges of values. Okay, so let's say we want to divide 0 by 2. Can you have a dividend of 0? Well, I think you can. Why don't we run this again? Okay, so we say we have a dividend of 2. No, we have a dividend of 0, and we have a divisor of 2, and it says the quotient is 0. So that's okay. Now we're going to test one of the classic computer math no-nos, which is to divide by 0. So let's run it again. Okay. We say that the dividend is 2. The divisor is 0. It's not going to like this one. And let's press return. Kaboom! So if you look down here, the final decision is 0 division error, integer division, or modulo by 0. So the integer division is the one that we're doing now. The modulo is that operator that gives you the remainder, which you're going to have to use on your own assignment. So you can't have a 0, okay? That doesn't make sense, okay? Because what would the answer be? Would it be infinity? I mean, how many zeros are in a 2? Well, it's not really defined. So it raises an error. All right, that's good. It's pretty good testing. Now, the only thing we haven't done is we haven't tried to give it non-integer inputs. Okay, we gave it a range of integer inputs, but not non-integer inputs. So why don't we run it again? And let's see what happens if we put a number that would be an appropriate input for a float, but not for an integer, like 3.0. It doesn't like that. So this says value error, invalid literal for int with base 10, 3.0. So you can't do that. Eventually we're going to learn how to capture that error and go back and say, oh, by the way, I wanted a proper integer. Okay. Oh, and it'll do the same thing on the second input. So we're not going to test that explicitly right now. And then let's see, what if we give it a clearly non-number response, like hi mom? Well, that's going to blow up too. Okay, so I think this is pretty well tested. Now, am I done? Well, I'm not done because I've got comments in the code that I don't want to, that I wouldn't want to put into my production code. Okay, what kind of comments are those? Well, your pseudocode, those are kind of your scratch pad area. Do you have to type it into the code? No, you could have had it on a piece of paper right next to your mouse. I put mine in here so you wouldn't, so you would be able to see it. So we don't want that. Okay. What other kind of comments do we don't want to leave in? Or what other kind of code do we not want to leave in? First of all, we don't want to leave in any dead code. So, for instance, if we've got some code that we were originally using, but we've kind of deviated around it in the program. Well, then we want to get rid of dead code that we're not using. We don't want it in there for the test or when we turn we put the code into production, which means it's for use by the using public. The other thing is people will sometimes they'll do things like this. They'll say, do I want this? Okay, do I want this code or do I want this other code? Maybe, I'm sure I don't want just a plain old division that would work either with floats or with mixed type variables. And you can say, so let's turn this original one into a comment for now. Okay, I'll see a lot of problems where the students finally decide and say, no, okay, I didn't want to change that, so why don't I put the new code into a comment, and why don't I put the old code in, why don't I uncomment that, and then they test that, and then they forget to take out the commented code. So we're gonna expect you to turn over the code to us for grading, for testing and grading, the same way you would turn it over to your client, which is to say, we don't want any commented out or unreachable code. We want this to be ready for prime time. And then the other thing to remember is every time you change your code, before you hand it in, you want to do one last test. Okay, did you accidentally break it when you were changing comments and stuff? Well, here we're going to run this again, and we're going to say down here, let's make this a little bit bigger. Let's say enter an integer for the dividend, let's say 30, and enter an integer for the divisor, let's say 20, and the quotient is 1. So now we're ready to go. Okay, so I just want to remind you, your assignment is going to be very similar to this, but instead of the quotient, you're going to be looking for the remainder. Okay, there you go. See you soon.